Okay, boys. So the vector calculus really is our fallback to our vectors knowledge and processes, but in terms our vector positions are actually given to us as a function of time. So really we're going back to our parametric equations. So I guess just a great example, the position vector RT, the I position, I component is some function of time, the j component is some function of time as well. And we use x of t, a function in x for the I component, a function in y for the j component, and a function of z for the z component. So our position vector RT can be written as some function of x of ti plus some ytj. So just keeping in mind, so the x value is x of t, the y value y of t, with the minus x squared plus y squared. Parameter is obviously time. Keep in mind that when we convert our parametric equation into Cartesian equations, x is equal to x of t, y is equal to y of t. Transpose to solve for what t is equal to and substitute back in typically. Don't forget the domain. The domain of that Cartesian equation that we come up with is given by the range of x of t, and the range of the Cartesian equation is given by the range of y of t. Okay, so just quickly in here, let's look at a few examples. If we want to find the Cartesian equation, we put x equal to 2 minus t. Let's put y equal to 3 plus t squared. Obviously a quick arrangement, t is equal to 2 minus x, we can substitute that in, and so I end up with y is equal to 3 plus 2 minus x squared. So we've got a parabola there, haven't we? Parabola there with a turning point at 2, 3. The domain of that function, or the range of 2 minus t, is R. Yeah. And the domain of 3 plus x, or 3 plus t squared, is going to be from 3 to infinity. And that ties in really what we know about a parabola. Okay. Secondly, again, x equals 1 minus cos 2t, y equals sine t. Don't forget when we've got our cos and sines transposed, get cos equals and sine equals, because then we make use of the Pythag identity. So that's what we've done here. So I know cos squared is 1 minus x squared, sine squared is y squared. If I add those together, I get 1. So there's 1 on the left-hand side. And again, the domain, 1 minus cos t. Well, cos t itself, the range of cos t is from negative 1 to 1. So the range of x equals 1 minus cos t is going to be 0 to 2. And the range of sine t is from negative 1 to 1. Let's keep working through. So find the Cartesian equation, state the domain of range. And sketch the graph. So again, there's cos squared there already and sine squared there already. So if x is equal to 1, y is equal to the other. X plus y, which is sine squared plus cos squared, is equal to 1. So there's my straight line graph, x plus y. Or y equals 1 minus x. But don't forget, the range of cos squared t is 0 to 1. So there's my domain. And the range of sine squared t is 0 to 1 also. So there's my range. So it's only that part of the graph there. So it's important to know. Again, x equals t, y equals 1 minus t. So we can just substitute in. So it's a line of y equals 1 minus x. The domain of t, the range of x equal to t is just going to be r. The range of y 1 minus t is also r. So we've got the full straight line this time, which is what we have over here. Set the Cartesian equation, domain and range of the corresponding Cartesian relation to sketch the graph. So same sort of thing. So we've got this time x equals 2 sec theta, y equals, sec lambda. y equals tan of lambda. So again, sec of lambda is x on 2. Tan of lambda is y. So if I square both of those, we use our Pythag identity to work out that tan squared plus 1 equals sec squared. So I soon get that x squared minus y squared equals 1. So obviously it's a hyperbola. So we know from year 11, so typically it's not going to be it's not going to be sketch the graph really in a year 12 exam. But what do I know? If x is equal to, if x on 2 is equal to sec lambda, so we have we have x is equal to 2 on cos theta. So we've got the range of that is going to be from 2 to infinity or from -2 to negative infinity, which is what we have. Y equals tan lambda. The range of that is r. So that sort of corresponds with our knowledge of the hyperbola. Okay, we're at -2 and 2 in terms of x-intercepts. We have our asymptotes there, which is y equals plus or minus b on a. So what's that? B is 1, isn't it? X on, yeah. So there's our asymptotes there and our domain and range. All right. Keep working through. Same sort of thing, isn't it? X equals, Y equals, rearrange, get the sine theta and cos theta on their own. Which is what we've done. Square both of them. So I get x minus 1 squared. I've just taken -2 squared is positive 4 plus y squared on 9 equals 1. So it's an ellipse. Again, think through your domain, the ranges of the corresponding sections. If x equals 1 minus 2 cos lambda, so cos of lambda has a range of values between -1 and 1. So I get as low or as high as 1 minus -2. So 1 minus 2, so that's -1 to 3. Similarly for 3 sine lambda, we're going to have an amplitude of 3, so from -3 to 3. And so there's my corresponding ellipse. Probably should have put a center in there somewhere. What's that center? 1, 1, 0, and we went up. Went up 3, didn't we, from the y value? So that's the point 1, 3, 1 minus 3. And we went 2 to the left, so we've got -1, 0. And on the right, we've got 3, 0. So that all corresponds with the domain and range that we've already decided on. Okay.